today we will be moving to the new topic, that is a gradually varied flow. So in a gradually varied flow, the depth of flow changes gradually with time, right? In a rapidly varied flow, I've told you the depth is changing rapidly. But if a gradually varied flow is there, means if water is flowing, the depth will be slowly increasing. That is called as a gradually varied flow. So before deriving any equation for gradually varied flow, the following assumptions are there in the gradually varied flow. The first assumption is the bed slope of the channel is very small. So the slope of the channel is small and the flow is steady and discharge is constant. That is the second assumption, that the flow is steady and discharge is constant. And the third assumption is accelerative effect is negligible and hydrostatic pressure prevails over the channel cross section. That is, the effect of acceleration is negligible and hydrostatic pressure is only prevailing over the channel cross section, and the energy correction factor alpha is 1 and the roughness coefficient is constant for the entire length. And next is the Chessy's-Manning's formula, applicable to uniform flow is also applicable to gradually varied flow. Like for determining the slope of the bed, you can use this equation, like SF is Vn by R raised to 2 by 3 the whole square, or SF is V by C root R the whole square. So these equations are also applicable to this gradually varied flow, and the channel is a prismatic one. So these assumptions are very important. So they may ask what are the assumptions in gradually varied flow, or if derivation is asked, you can write first the assumptions, point the assumption and then do the derivation part. Now the next topic which I am going to discuss is the equation for gradually varied flow, which is a very important equation. So if the derivation is asked for 10 marks, write down the assumptions for gradually varied flow and then you have to derive the equation. Next topic is the derivation of this gradually varied flow. That is a equation, dynamic equation for the variation of this gradually varied flow. This derivation is very important, so please listen carefully. For this, first you are considering a flow, an open channel flow. You are considering this is the bottom of the channel and this is the datum portion. So this channel bottom is at a distance Z from the datum, and here if you are seeing this is the potential energy value, that is the Y value, the depth of water here, and V square by 2G is the kinetic energy there. So energy line will be here. Okay, so the total energy is the sum of all these values. So the total energy line is here. So if you are taking a channel bottom along the x direction, if you are taking, the slope of this channel bottom is say S0 and the slope of this energy line is SF. Okay, so this is, if a small slope is there, then only the water will be flowing under the force of gravity, right? So this is an open channel where the water is flowing, where here is the depth of that water, Z is the distance of this channel bottom from the datum, and this is the energy, this is the kinetic energy value V square by 2G. So the total energy is the sum of Z plus Y plus V square by 2G. So you can write the total head or the total energy with value H is Z plus Y plus Z plus Y plus V square by 2G. Now V, you can write the velocity, discharge is area into velocity. So velocity is discharged by area. So you can write H is equal to Q square by A square into 2G plus Z plus Y. Now if the flow is along this x direction, so you can take the derivative of all these terms with respect to x. So dH by dx is equal to Q square by 2G is a constant term, Q square by 2G 1 by A square into derivative with respect to x is dA by dx plus dZ by dx plus dy by dx. All I have taken in with respect to x. Now the derivative of 1 by A square is A raised to minus 2, right? A raised to minus 2 derivative is minus 2 A raised to minus 3. So minus 2 A raised to minus 3 I have written here. So the equation is like this. So finally dH by dx will get as minus q square by Ga cube dA by dx plus dz by dx plus dy by dx. So when x increases, this h and z are actually decreasing. With x, this h and z are decreasing, right? So this value, this dh by dx means what? The total change with respect to x. So that is the slope of this energy line, right? So dh by dx will give you the slope of this energy line. The negative sign because x increases, h and z is decreasing. So here it is minus SF, that is the slope of the energy line, minus q square by Ga cube dA by dx plus dy by dx, and dz by dx means what? It is the change of this channel bottom with respect to x. That will give you the slope of this channel bottom, that is S0. That also is minus S0. So what you have to do is this dA by dx term you have to write in terms of dy by dx. How you can write it? dA by dx you can write as dA by dy into dy by dx. So here dA by dy is called as a channel top width, that is T into dy by dx. So dA by dx you can write as T into dy by dx. So here in place of dA by dx I have written T into dy by dx, and if you are rearranging the equation you will get S0 minus SF is S0 minus SF is dy by dx. If I am taking outside, dy by dx 1 minus q square T by Ga. Or dy by dx is S0 minus SF 1 minus q square T by Ga. Or this q square T by Ga is also called as a Froude number. So S0 minus SF 1 minus Fr square. So this is the equation for gradually varied flow. The same equation, Froude number is V by root Gh, right? It is the equation of Froude number. So this equation can also be written as dy by dx is S0 minus SF by 1 minus V square by Gh. Sometimes in the problem they may give you the velocity value. So in that case you have to use this equation. So in most of the text this equation is also used. So all these values are also used to find the value of dy by dx. And if this value, the change in this depth value along this x direction, if it is 0 means what? This S0 and SF is equal. So in that case the water surface is parallel to the channel bottom. The water surface will be parallel, right, to this channel bottom. It will be parallel to that. And if dy by dx is positive, that means if this value whatever you are getting is positive, the water surface is rising, and if this dy by dx is negative, then the water surface is falling. So this is an important equation for gradually varied flow. Problems may be asked, also sometimes derivation may be asked for 10 marks. If derivation is asked, let's write the assumptions, draw this figure neatly, explain the figure, and find these derive this equation and write all these three conditions. This is the equation for gradually varied flow.